Ah, just coming off of a illness. Caught the cold. It is what it is. Hello, and welcome to Chapter 1 of Generative Energy. Chapter 1 of Generative Energy by Ray Peat. Spoken by Happy Man, me. I wanted to create a easier to digest and consume version of generative energy so that more people may actually understand like the more core ideas of peating instead of just listening to other people repeat their interpretation of it. Now, I will leave my interpretation, and I attempt to remove any input. I really just try to interpret it in a layman sense, so that the more technical aspects of what he's talking about are more digestible. Now, I'll leave my summary of Chapter 1 and all of its individual parts at the end of this video, or I will make it a video within itself. But right now, I will just read Chapter 1 of Generative Energy in audiobook form to you. In this book, I offer some practical methods for solving health problems by increasing biological energy. The methods can be applied by people to themselves or by physicians to their patients. But energy and individuality and thought are so closely associated that full access to the value of these techniques might require the integrated and balanced approach that can be provided by a new theoretical orientation. I offer some suggestions on the way our inner world can mesh with the outer world in such an energy-based orientation, and the outer world in such an energy-based orientation. And the theory might not be of general interest unless its meaning can be concretized in some specific situations. Other people are working on the same kinds of theories, and other people have worked out parts of the various techniques, but my effort here is to offer something like a technology of life which unites theory and practice. I intend to show that the human substance isn't simply a metastable transient event, but that it is rather a pioneering probe into a new system. Self-organizing systems decay only if they have assimilated inertia, and, with a little support of the right kind, the centers of degeneration can become centers of regeneration. Biogenic simulators, adaptogens, spontaneous healing, cancer, aging, and reproduction are considered here in light of the best available knowledge of developmental systems in biology and non-equilibrium processes. Besides having a practical value of bringing coherence into our understanding of some things that might have been merely therapeutic approaches, I hope it will also shift the theoretical focus in the study of self-ordering processes away from the informational statistical and towards the energetic, to interpret structure, phase, and state in terms of energy and history before considering their abstract, informal properties. Part 1. Aspects of wholeness. Once we begin to believe in the future, we understand the possibility of learning more and being more. We appreciate the unexpected, and we even anticipate the opportunity to confront it. There is an inertia that makes it easy to overvalue present knowledge. If we have enough energy and enough time, we overcome the inertia. The desire for wholeness can lead us towards a more appropriate kind of science, and also towards a more perfect world. Holism, Chapter 1, Aspects of Wholeness. Holism is the observation that, although natural objects can be resolved into their parts, the parts are to some extent shaped by their participation in the whole object. For example, in organic chemistry, it is recognized that the reactivity of an atom or radical is modified by adjoining parts of the molecule, by the solvent, etc. Holism would have been named, except that it is so common in our scientific tradition for someone to say, "We know all there is to know about the parts, atoms, surfaces, fields, genes, etc., so we can foresee the result of their combination. Good engineering involves knowing the properties of the materials so thoroughly that accurate predictions can be made about their behavior, but good science requires a willingness to accept the unpredicted when it occurs. Holism, or a non-dogmatic attitude towards the world, recognizes individual uniqueness rather than averages and is likely to look for complex causes, especially environmental influences, rather than too easily ascribing traits to the genes. Historically, a resistance to distinguish our present knowledge of something from its real existence and fullest potential has characterized most of the people who oppose holism and call themselves reductionists. Consciousness, perception, sensation, pleasure, and intention have often been omitted from the world described by reductionists. If we are going to understand life and its possibilities, then it seems that we should begin with an appreciation of its liveliest aspects as an essential dimension of our thinking, even if we are going to work with some of its relatively inert aspects, such as viral genetics. The relation of energy to structure is, I think, the central question of biology. The importance of the same question for the physical sciences might indicate a rough way of how Haldane's predicted swallowing up might occur. The ideas of resonance and hysteresis, which are only vaguely defined in physics, have to do with the interaction of energy and structure on various levels of complexity and organization. And are examples of physical concepts that gain meaning and clarity from biology. When energy flows through matter, order accumulates, as a result of resonance and hysteresis, for example. But we hear so often about entropy, randomness, and symmetry that we forget most of the formative processes in the material world. Human and ecological health obviously should have the benefits of holistic science, but the actual situation is that biology and medicine have become very product-oriented, and holistic considerations are increasingly left to a variety of fringe occupations. Many of these alternative approaches are concerned with the idea of energy as a key to health. In general, they lack simple and effective methods for optimizing biological energy, and often use counterproductive methods such as prescribing linseed oil nutritional supplements. In the following pages, I will show how some of the most important achievements of ordinary science can be retrieved from the distortions of the medical promoters and made available for holistic use. That is, for appropriate use. Non-genetic biology. The word gene itself contains an ideology, since it implies origin or genesis, though its main meaning is something like a unit of continuity. Building on the world's connotation, dogmatic geneticists explicitly stated their central dogma, that information flows only from DNA to RNA and only from RNA to protein. When Tenen in Baltimore described the reverse transcription of DNA from RNA, all the professional biologists I talked to said flatly that they didn't believe it was possible. Even when no one was threatening the addition of information to the chromosomes, the dominant belief among biologists was that development was closely controlled by the genes, because the body owes its genesis to the genes. Intelligence, body of proportions, and senescence were said to be specified or governed or programmed by the genes. The congenital condition was often taken as the genetic condition. Textbooks said that the maternal influence was only genetic because the fetus was insulated from events in the mother's body, just as the germline was isolated from events in the rest of the body. Although many kinds of experiment showed both prenatal and transgenerational influences of the environment on intelligence, body proportions, and rate of aging, the genetics reductionist school ignored them and defined themselves as the only scientific school of biology. I'm going to take a drink here. Energy and the brain. When I was a student of literature, I was interested in the apparent energy differences between different writers and different social groups. The literature of dissent, I wrote my master's thesis on William Blake, always reveals an abundance or excess of energy. I came to see literary periods or styles, classical, realist, romantic, surrealist, etc., as reflections of a society's energy and structure. As I followed this line of thinking about the function of languages in society and in the life of the individual, I saw that Blake's descriptions of his own use of images and symbols made sense in relation to brain physiology. Even attitudes towards mathematical concepts, theories of ideal languages, and language philosophy related strongly to the person's attitude towards authority, energy, the body, and the nature of consciousness. After I had spent a few years studying and teaching linguistics, I decided to study brain physiology. At the time, a group at the University of California had already found that freedom and stimulation caused a cumulative transgenerational increase in the size of rats' brains. Continuing that work, Marion Diamond had found that pregnancy or progesterone treatment increases brain size and inhibits the development of age pigment, suggesting that longevity might also be increased. In 1968, another group found that prenatal hormone treatment causing increased production of progesterone greatly increased the intelligence of rats. Several researchers have shown that brain size relates strongly to both energy production and longevity. A graph suggests how adaptive mental energy and longevity might relate. At a certain stage of gestation, there are more than twice as many brain cells as there are at the time of birth, and it is likely that good conditions for the mother and fetus, adequate blood volume, oxygenation, glucose, progesterone, thyroid hormone, and absence of toxins and nutritional imbalances can preserve some of the cells that would normally die. Since the brain and liver regulate the amount of glucose and hormones in the body, the conditions under which those organs develop will likely influence their later functioning and account for some of the transgenerational effects that have been observed. Mechanisms of aging. As I became aware of the influences of hormones and the availability of energy on the development of the brain and the effects of the brain on aging, and became aware of the amount of dogma in the neurosciences, I began to work on the ways in which energy metabolism affects reproductive failure, especially in the senescent decline of fertility. I hope that working in a less dogmatic area of physiology would allow me to get a better understanding of the organism in general, including the brain. Professor Soderwall and his students at the University of Oregon had shown that the corpora lutea, areas in the ovary which mainly produce progesterone, appeared to fail in aging hamsters, and that vitamin E supplements could extend fertility by a significant amount. His group showed that aged ova were not responsible for infertility, but rather that the uterine environment was not suitable for implantation. Soderwall had also demonstrated that excess estrogen could cause failure of the pregnancy at any point, from the failure of the embryo to implant to the reabsorption of the fetus at a late stage of pregnancy. Although I had investigated the association of estrogen with cancer and knew from my own experience with migraines that stress, diet, and hormones interacted in powerful ways, when I began to investigate the oxidative metabolism of the uterus, I didn't realize that it would involve a convergence of several of my main interests. I was familiar with Otto Warburg's famous idea that cancer is caused by a respiratory defect, and I knew that aged tissue has a diminished respiratory capacity. The textbooks indicated that estrogen deficiency and aged ova were responsible for senescent fertility. The origin of these ideas in a dogmatic matrix is another story which I have told elsewhere. I found that the uterine endometrium of old animals often consumed oxygen at a high rate and showed other signs of being under the influence of excessive estrogen. As I tried to understand this, I found that the uterine endometrium of old animals often consumed oxygen at a high rate and showed other signs of being under the influence of excessive estrogen. As I tried to understand this, I saw that several things could contribute to the high rate of oxygen consumption. Either too much estrogen or too little progesterone could have the same effect, since it is a ratio between these two hormones which controls their effects. A vitamin E deficiency increases oxygen consumption, and too much unsaturated fats have the same effect. In a vitamin E deficiency, unsaturated oils are oxidized in a way that produces age pigment. also called ceroid pigment or lipofuscin. This pigment consumes both oxygen and fuel, but produces no usable energy. Estrogen excess synergizes with a deficiency of vitamin E to intensify the formation of this pigment. Partly, this might be because estrogen is a powerful stimulant of iron absorption, and iron is involved in the peroxidization that produces the pigment. But low oxygen concentration is what causes the iron to become active in peroxidization, and estrogen acts in several ways to decrease the availability of oxygen. It appeared, therefore, that many of the features of aging resembled an estrogen excess rather than estrogen deficiency. The way in which estrogen prevents or terminates pregnancy seems to be by causing the uterus to consume oxygen at such a high rate that there is no oxygen available for the embryo, which has a high requirement for oxygen beginning on the day that it normally implants. The chronic or cumulative effects of estrogen, leading to the formation of lipofuscin, happen to act in the same direction of estrogen itself, causing oxygen to be reduced, especially in the uterus, but in all other tissues too, aging the entire organism. Estrogen excess can also destroy the corpora lutea, interfering with the production of progesterone. Progesterone's effect in pregnancy is to assure the availability of oxygen and nutrients for the embryo, but it also has the general effect of inhibiting the formation of lipofuscin and of other aging signs by improving efficiency. Progesterone is unusual among the anti-stress steroids in having no harmful side effects. Although my work confirmed the other research that had been done in Soderwall's lab in the preceding 25 years, the idea that estrogen's influence appears to increase with aging and even to contribute to the process of aging was contrary to the doctrine that had been promoted by the pharmaceutical industry. Nevertheless, as I read more, I saw that there was really no evidence contrary to what I had seen in my own work. What existed was a web of interpretation which existed to sell estrogen treatments. Even the fact that estrogen caused abortion was ignored, very consciously, until the industry had fabricated a more acceptable rationale in which to sell its contraceptive pills. The idea of many factors acting in the same direction and tending to have a cumulative effect seemed to me to have a general biological significance. It seemed to be part of the answer to the question of what it is which is lost or accumulated during aging, which accounts for the decreased ability to adapt to the changing environment. It seemed to say something about the nature of Warburg's respiratory defect in cancer. The thyroid hormone, which governs respiration, is suppressed by estrogen and by unsaturated fats. The wasteful metabolism of estrogen dominance tends to use up glucose and is likely to activate the stress hormones, including cortisol. The main features of aging can be produced directly by administering excessive amounts of cortisol. These features include atrophy of the skin, arteries, muscle, bone, immune system, and parts of the brain, loss of pigment, melanin, deposition of fats in certain areas, and slowed conduction velocity of the nerves. The physiology of aging, especially reproductive aging, overlaps the physiology of stress. Life expectancy of adults. When there are sewers and clean water, the death rate of infants and children from infectious diseases isn't high, so the average age of the population increases as a larger percentage of those born live into old age. Increased use of birth control will also increase the average age of the population if fewer children are born each year. These changes in the birth rate and infant survival can happen at the same time that industrial pollution is causing chronic poisoning, which shortens the lives of mature people. To understand the effects of aging on the risk of human disease and death, we need information specifically about people who have reached a certain age. There are several organizations and individuals in the U.S. that have cleverly used re-standardized statistics to convince the public that cancer is being defeated. Industrial pollution is harmless, sickness is caused by the victim's own irresponsible choices, and that our longevity has increased by several years in the last few decades. Old people are the most likely to die of cancer, and the cancer death rate for old people in the U.S. has been increasing in recent decades, as has the cancer death rate for the population in general. The life expectancy for older people in the U.S. has barely increased a year in recent decades. 2,000 years ago, the life expectancy for older people seemed to have been several years longer than it is now. Puberty and aging. Many studies have demonstrated that puberty seems to trigger the mechanism of aging, and the idea of a death hormone located in the pituitary gland has been suggested. Many degenerative diseases develop under the influence of excessive estrogen and cortisone, and as a result of the many metabolic changes which follow exposure to those hormones. Many of these diseases, especially those which appear after puberty and are more frequent in women, can be treated very effectively with the anti-estrogen and anti-stress hormones, such as progesterone. Hans Sale pointed out that estrogen treatment mimics the first shock phase of the stress reaction. An excess of estrogen, or any stressor, causes the pituitary to secrete prolactin and ACTH, and both of these hormones act on the ovaries to stop progesterone production and contribute to many other ways to process atrophy. ACTH, of course, simulates the secretion of cortisol. The removal of the pituitary obviously isn't a practical way to delay senescence, but protection against the death hormones that can be achieved to some extent by altering the diet to minimize the effects of estrogen and cortisol. Historical and demographic studies show that certain conditions affect the age at which puberty occurs. Ashley Montague, has argued that we need more neoteny. That is, that we should try to preserve and to extend our youthful functions, because those are our most human qualities. If we can generalize from animal studies, delaying puberty could increase the brain and longevity, improve intelligence, decrease violence, and even make people physically more attractive. The cute puppy appearance is largely a matter of brain size in relation to the size of the face and body. I think this will be the next step in human evolution. Just as nurturing, stimulation, and freedom promote improvement in the function and structure of the brain, cruelty and oppression act in the opposite direction. If puberty is delayed, then the importance of a culture which supports curiosity, exploration, play, and sensuous pleasure seems obvious, so that biology and culture will be mutually supportive. The physiological age of the parts of an organism depends in some way on the developmental stage of the whole organism. This contradicts the reductionist idea that cells or tissues have an intrinsic lifespan, which will cause them to deteriorate after a limited number of divisions. When pieces of breast tissue or skin were repeatedly transplanted from old animals to young animals of the same syngenetic strain, they were still in good condition after 10 lifetimes, and their survival was apparently only limited by the necessity of trimming them each time they were transferred, to make sure that no host tissue was transplanted with them. When old rats were grafted onto young rats, the old member of the pair lived to twice the expected age. Recently, young female mice were grafted onto old females to investigate any hormonal factors in aging. The ovaries of the young animals appear to age, and its production of progesterone decreased. That is, old tissue seemed to become younger on young animals, and young tissue can be aged by association with an old animal. This kind of evidence, and the simple observation that the cells in skin and intestine undergo thousands of divisions in an individual's lifetime, strongly favors the idea that a systemic energy problem is involved in aging. Oh my God. It's intense. That is intense. Man, what the fuck? I just realized drinking that milk that I have floaters in my eyes. This is crazy as fuck. Energy and evolution. Verdansky believed that the Earth's energy exchange and substance exchange processes were intensifying, and that the biosphere would undergo another major increase in its metabolic rate, similar to that which appeared early in life's development and with photosynthesis. M.I. Buteyko, in Evolution of the Biosphere, discusses the principles of aeromorphosis, in which the origin of higher types of animal is closely associated with the availability of larger amounts of energy in the environment, and with the appearance of new structures which made possible a higher energy level of activity and more complex interactions with the environment. When vertebrates developed an effective method of heat regulation, they were able to considerably increase their use of energy. The move from water to land requires great ability to use energy, as well as requiring new structures suitable to the new way of living. When mammals and birds achieved the ability to sustain a high metabolic rate by keeping their bodies at a steady, fairly high temperature, their food chain, based on photosynthesis, consisted of organisms that generally lived at a lower temperature. Sugars, proteins, and saturated fats produced by warm organisms can be eaten by warm-blooded animals with no particular side effects. Organisms that live at lower temperatures, however, contain unsaturated fats. The consumption of large amounts of unsaturated fats lowers the metabolic rate, and accumulated unsaturated fats are susceptible to a spontaneous and toxic form of oxidation. The toxic effects include damage to the respiratory apparatus and to the circulatory and immune systems, increased rate of aging, and cancer. These low-energy foods, in effect, counteract the evolutionary achievement of a high metabolic rate. Several studies show that decreased consumption of unsaturated fats can delay puberty. Other studies show that an excess of unsaturated oil in the mother's diet can damage the development of the fetus's brain. The choice of foods which have less unsaturated fats tends to reinforce the achievements of evolution. The seed oil industry has created a national phobia about the consumption of saturated fats and cholesterol, but there's no basis for the idea that those foods should be avoided. People with hypothyroidism are susceptible to heart disease, but their elevated blood cholesterol becomes normal when their thyroid function is restored. The body's highest concentration of cholesterol exists in the brain. The level of cholesterol in the blood strongly influences the production of the protective hormones, such as progesterone. The brain contains by far the body's highest concentration of these hormones. Another energy-promoting factor is visible light. In the winter and at night, the respiratory energy producing in the system is damaged, and the protective hormones decline, and the harmful stress hormones increase. The immune system becomes less active, and mortality increases. Although ultraviolet light interacts with unsaturated fats in the skin to accelerate aging and to produce cancer, ordinary visible light has several beneficial effects in animals. One effect is the regeneration of the enzyme SOD, superoxide dismutase. By causing its copper atom to be reattached to the protein, light also increases the activity of normal respiratory enzymes and tends to normalize or maximize the production of hormones, including progesterone and thyroid. Animal migration to reproduce in regions with longer days is a way to benefit from this energy-promoting action of light. In adult birds, the increase of hormones in the spring causes the growth of new brain cells in the area that controls their singing. In humans, the space inside the cranium keeps increasing into old age, and the amount of DNA in the brain also keeps increasing with age. But it has been assumed that such changes in adult brains result from an increase in the size of nerve cells and an increase in the number of connective tissue cells, rather than from a continuing increase in the number of nerve cells. I would expect an increase in the temperature of the Earth and increased use of artificial light or migration to lead to a prolongation of youth and the development of better brains. Many years ago, people talked about the tendency towards cephalization in evolution. That is the tendency to create a hierarchical organization with the size and importance of the brain increasing with evolution. More recently, it was found that both the intensity and the efficiency of respiratory energy production in the brain increase with evolutionary level and with the degree of alertness. Another seemingly directional tendency relating to energy production has to do with a non-random composition of the DNA. Aerobic microorganisms' DNA has a higher G plus C, the base's guanine and cytosine content, than does that of anaerobes and warm-blooded vertebrates, have more G plus C than do lower organisms, with the G plus C content again corresponding to the amount of oxygen used. Although the full meaning of the G plus C content isn't known, It is thought to affect the stability of the organism at various levels, and I suppose this would allow the organism to thrive at higher temperatures. The association of G plus C content with evolutionary level is interesting because the changes occur in non-coding DNA, where the ordinary kinds of selection involving coded proteins isn't involved. The isolation of the genome and the randomness of its changes used to be at the core of genetics. I suspect this is why most biologists aren't aware of this odd feature of DNA composition. The passage of time will allow people to disengage themselves from an embarrassing dogma. That was part 1 of my recording of chapter 1 of Generative Energy by Ray Peat. Now, I will be honest, I'm not the greatest at speaking, but hopefully I can edit this into something that is listenable. And if you're listening to this right now, that means I was successful. Soon I should have the other parts of Generative Energy up, at least chapter 1. Chapter 1 is incredibly lengthy. It is pretty much him establishing the basis for the rest of the book. So it's very dense. It includes a lot of very different ideas all smashed into one, but they all work and weave together in a very beautiful way. And I hope you enjoyed this reading. Goodbye.